Welcome to homework.
35.104. This is an experiment called Lloyd's mirror. So we have a single slit through which light will diffract, and then instead of having another slit or something, we have a mirror. And this lens is just here so that the screen is at the focal plane of the mirror, and we can pretend it's infinitely far away, and otherwise we don't think about the lens. So basically we have light traveling directly through the slit, interfering with light that bounces off of the mirror, and we want to think about what happens. The first thing is the question of, is the fringe that corresponds to a zero path length difference bright or dark? Now we know from a two-slit experiment that in that case, when the path lengths are equal, the interference is constructive and it's bright. However, when the path length in general, the reflecting off of the mirror will cause a phase shift of pi radians. And so then if the path lengths are equal, what ends up happening is that they have no change in phase due to their travel distance, but one of them got a phase shift of pi, or half a wavelength, on its way from reflecting off the mirror. And so the S ends up having a dark fringe corresponding to zero path length difference. And in fact, then we can realize that this is going to behave exactly like the Young's double slit experiment, except dark and light fringes are going to be interchanged. Because the mirror sort of acts as, you can think of the mirror as acting like a virtual source of light somewhere over here. This is not drawn very well. That then that is pi out of phase with the other source. So it's exactly like the normal double slit experiment, except one of the sources is out of phase, and so the bright and dark fringes are reversed. And knowing this, we want an expression for the bright fringes and the dark fringes. And so we can just take what we know from the normal double slit and swap them around. So we'll have 2h sine of theta equals m plus 1/2 lambda. And here we'll have 2h sine of theta is equal to m lambda. We can see indeed that theta equals 0, m equals 0, and that would be the central, now here, dark peak in the intensity.